So I'm actually going to introduce Simon Swan for you to start with. He's going to open up this session for us for about 10 minutes. To introduce Simon tonight, he contributes to the core technology of synthesized. You'll hear more about them later on, and he's the machine learning lead. Simon is passionate about algorithmic and AI fairness, so we've got the right person in the right place here. And he's also the product lead for Fair Lens, a really interesting product that I shared actually with the community earlier on. So synthesized open source bias measurement and detection toolkit, right? That's what Fair Lens is. So prior to joining them in 2019, he was in the legal and medical industries as an NLP and machine learning engineer. He has an academic background, statistical thermodynamics and computational linguistics from the University of Cambridge. I thought that's where we knew each other from. Simon, of course, now I remember we were classmates. That's not entirely true, but it's very good to see you. I'm looking for you on my screen. There you are. I'm going to put you here as a spotlight for everybody. Simon, the stage is yours for 10 minutes. Please open this session for us. Tell us what you think about this question. And thank you so much for being here today with us.
Yeah, cool. Thanks, Richard. I'm really excited to be here. I think it's a fantastic opportunity. We're going to get to discuss something that's so important. Especially as data truly begins to dominate our lives. The way I see it is we live in a world of uncertainty, and every day we're having to innovate and create solutions where we don't really have the full picture. A good example of this is with music suggestions on a platform like Spotify. So Spotify has the challenge of suggesting songs, and they suggest them to me based on an incomplete picture. They only have access to some of the songs I've listened to in the past, and as a problem, they're trying to give me the best songs as possible, with this limited information. Yeah, and they do this quite well. They use other sources of information, other users' behaviors, and try and find some trends and generalize from this incomplete information. And they suggest new songs that, for the most part, I like. The problem is this doesn't always work for everyone. Other people get bad suggestions, and that can be purely just down to the fact that they like music that Spotify doesn't deal much with. The engineers, the ML engineers that were working on these algorithms, maybe they weren't aware of certain types of music, or there's just the data that they were using doesn't contain enough of these types of information, these types of songs, for them to get reasonable suggestions. And this isn't that big of a deal. It's just
apologies, Simon, back with you.
All good?
Mm-hmm.
Okay, cool. Yeah, so it's not that big of a deal. It's just someone not getting the songs that they like. But this is just the start of a problem. We then think about artists that make music on Spotify. Certain artists are going to develop certain types of music that don't get suggested to the general audience, and this can create a feedback loop where because of some algorithms haven't necessarily been able to with confidence suggest these songs that are less commonly played, less commonly heard. These artists then suffer. They don't get their music heard. Their music then never gets big, and so no one listens to that music, and the cycle sort of continues. And this is where we start to see a bit more of a consequence. Now you have some sort of systematic discrimination to a group of workers based on the types of music that they're wanting to create. So we're at this pivotal point in history, and we're trying to use machine learning and AI to make more and more powerful decisions, more powerful than than we currently make. And we're doing this in this similar fashion of we don't have the full picture, but we have access to more and more data, and with that more and more data, we assume that we can make these, I guess, more and more powerful decisions. And for a significant part of this, recently, I've sort of bared witness to situations where this starts to go wrong. People haven't considered all of the sort of scenarios that their algorithm that they've sort of used is going to sort of be used on, and that starts to bad things can happen. So a good example of this is actually sort of a personal experience of mine. So I worked as a machine learning engineer for a hospital, and we developed an app to help detect and classify skin lesions, whether or not they were potentially dangerous, to try and encourage people to come in and see the doctor. And it was impressive in the sort of the test case, the limited test scenarios that we had. But you could take a photo of anything, firstly. So depending on other things in the background of that image that we might not have tested, there can be some weird effects that start happening. People don't understand, we don't understand fully how these models that we're making are sort of making their decisions. And this starts to have, like bad consequences. If you take a photo of a skin lesion and you've got a ring on your finger and that's in the photo, that can significantly impact the model, because the model's never seen that before. And it's just a good example of, it's hard to think of every single situation when you're designing these things that are making decisions more complicated than humans can, at a sort of a higher accuracy, at a higher sort of, at a higher performance. And so, the sample of data that we had used had introduced bias. And that was because, I guess the effect of that was people with different colored skin, to the examples that we used to make these models, didn't have as good a performance with this product. And so then you have someone who's suffering or not getting this tool that, and not getting the full effects and benefits of it, because of this. So there are lots of these sorts of situations and scenarios that we're sort of stumbling into, and it's coming up more and more in the news, and we really need to think about how we can start to build algorithms that are explainable, auditable, and transparent. Unfairly biased data, it really requires a collaborative solution. And I believe it's our responsibility to work with the wider community. We need to learn and understand how it can affect different people. And we want to then develop these sorts of innovations and drive more awareness to create solutions that properly deal with bias and to build a more equitable and inclusive society. And so with that sort of in mind, I'm really looking forward to the discussions that we're going to have today about how we can tackle some of these issues, and also to learn a little bit more about some of the pitfalls that have happened.
Simon, thank you so much. I really appreciate you opening up the conversation for us today, and with your kind agreement to join the panel later on, and perhaps share some more specific examples of your work and what you do in this area to combat this.